Good morning, students. So today we're going to solve question 32 from GATE CSE 2024 set 1. The question states that A and B are non-empty finite sets, right? And there exist one-to-one and onto functions from A to B and A cross A to A union B, right? The number of possible values of mod of A is, right? This symbol is mod of A, which is basically gives us the number of elements in the set, right? And that is not exactly what is being asked to us, that what is A mod, right? They are asking the number of possible values of A mod. Suppose that A mod is equals to 1, 2, 3, then the this is your set of all possible values of A mod, right? So the mod of this set is the thing that they are actually asking us, the number of possible values of A, right? Number of possible values of A, right? Now let's understand what is the meaning of this function and this special restriction that is being imposed, that this function should be of one-to-one and onto, that must exist, that there should exist of that sort, right? Such that it is giving us such that, so there should exist of this sort, right? So a function, let me revise you, is basically a relation in which for every element in A there is a corresponding element in B, right? For every element in A there is a corresponding element in B. The corresponding element need not be unique, right? The corresponding element can also be same. For two elements of A, the corresponding element in B can be same also, and the whole of B need not be occupied. There could be some elements in B that are not being pointed to by the functions mapping to any of elements in A. That is also possible. So this is what a function. If there exists a function from A to B, that does not really imposes any restriction on the size of A and the size of B, right? But if this function is of one-to-one type, then there are some restrictions which are being imposed. What are they? Well, let's understand. For one-to-one, for a function to be a one-to-one, the overlap that existed in B in normal functions is not allowed, right? If this is not allowed, then the function would be of this sort. There is nothing being said upon here about the rest of the elements in B that are not that could be present there, right? So for every element in A there is a unique corresponding element in B and then some leftover elements, right? So the size of B must be greater than size of A, and that is what I've written over here. That's a valid deduction that can be understood, that for one-to-one functions from A to B, the size of A would be less than size of B. Only if this is the case, then can there exist a one-to-one function from A to B, right? So we have this over here. Then there exists a onto function concept, right? In onto function concept, these extra elements of B are not allowed, right? These extra elements of B are not allowed. But the overlap, nothing is said about the overlap, right? So overlap can exist. So as you can see from here, there are 3 elements in A and there are 2 elements in B, right? And there are no excess elements present. So as you can observe, the size of A would be greater than B, and not just in this case, always, because if the size of B were to be greater than A, right, then there would be some leftover elements. Because even if there is no overlap, there would still be some leftover elements, right? So the equality condition exists if there is no overlap also. But if B is greater than A, then there would be some leftover elements. There is no way to avoid that, right? So this condition must be true, that size of A is greater than or equal to size of B for an onto function from A to B to be definable, to exist, right? And they are giving us that a onto and a one-to-one function does exist, right? Both of this condition also and this condition also exist simultaneously. I have written here that these are the conditions that are being coming because of one-to-one and onto, right? A is less than or equal to B and A is greater than or equal to B. Now both of these can only be simultaneously true if A is equals to B, right? So this part of the question specifying that onto and one-to-one and onto both exist, both kind of functions exist, that means that your A is equals to B. That is the thing that they are trying to tell us, right? With that understanding, if we were to apply it to this case, A to B, then the size of A is equal to size of B, right? And for A cross A union B, we have the size of this is equal to this, right? I've assumed here the size of A and B is represented by A, right? And this A would be a natural number because obviously speaking, a number of elements, the size of a particular set represents the number of elements that are present inside of that set, and that can only be a natural number only, right? That can only be a natural number only. So we have this part. Then A cross A is equals to A union B, right? Now A cross A is a Cartesian product of A cross of A with itself, right? So I hope that you must have learned, must have the concept of Cartesian product. If you don't really have the concept of Cartesian product, I would highly recommend that you watch a YouTube video on this Cartesian product concept. You will find many of them on YouTube. Then once you have found the concept, I have just represented over here the thing that is presented for a Cartesian product that is being taken for A being equal to 1, 2 and 3, 1, 2 and 3, right? This is the result of the Cartesian product, right? This is the result of Cartesian product. This can also be visualized to understand it, that why is this giving us your A square in the end. This is a good visualization that I have created, that you can understand once you have understood the concept of Cartesian product. Please watch that video and come back, or if you have already if you already have understanding of Cartesian product, please pause the video here and try to understand how the mod of A cross A is giving you A square, right? It's very straightforward actually. So we have this left hand side of the equation that was generated as A square. The right hand side, A union B whole mod, is still left, right? So what can be the size of this, man? What is the minimum size that is possible? The minimum size that is possible would be given if both of them are overlapped completely. Both of them are overlapped completely. In that situation, the size would be minimum. And what would be the size? The size would be your A, because size of A and B are equal, and that is represented by A, right? So size would be equal to A. But suppose that the elements, the A and B are not same, they are completely distinct. So that is the maximum size that A union B can take, right? So your size of A union B will vary from A to 2A, right? Will vary from A to 2A. So let's take a variable and represent this in a more arithmetic manner, right? So that can be written as x times your A, which is equals to A square, right? Where x belongs from 1 to 2, both included. That is 1, then 1.1, 1.2, and all possible elements that may exist from 1 to 2, and then 2. Both. This is the possible values of that x can take, right? So now x is a number that we have here. Now on both LHS and RHS, your A is present. So you can cut A from here and A from here. So A is equals to x. Now remember that A is a natural number. A is a natural number. As we have already understood that A represents the size of that is the number of elements inside of a set, right? So a set can not have a fraction as the number of elements it has, right? So x, what are the values of x for which it is a natural number? The values are 1 and 2 only. So A can take the value of 1, 2, right? A is basically assumed to be the size of A. That is what we have to find. Now that is not we have to find. We have to find this. If this is the set that if this is the set of the possible values of A, then we have to find this, right? And this is equals to your 2. This is equals to your 2, and that is your answer. That is your answer, right? That is your answer is 2 for this question. I hope that you learned something. Thanks for watching. Have a good day.